Bismillahirrahmanirrahim. Assalamu alaikum. Today we are going to discuss about system models. The outline of the topic include context models, process models, behavioral models, state machine and data flow model. Then semantic data models. First of all, system modeling. System modeling helps the analyst to understand the functionality of the system, and models are used to communicate with customers. Different models present the system from different perspectives. Number 1, external perspective showing the system's context or environment, behavioral perspective showing the behavior of the system, and third one is structural perspective showing the system or data architecture. Model types. Data processing model showing how the data is processed at different stages. Composition model showing how entities are composed of other entities. Architectural model showing principal subsystems. Classification model showing how entities have common characteristics. Stimulus or response model showing the system's reaction to events. Context model. Context models are used to illustrate the operational context of a system. They show what lies outside the system boundaries. Social and organizational concerns may affect the decision on where to position system boundaries. Architectural models show the system and its relationship with other systems. The context of ATM machine. Process model. Process models show the overall process and the processes that are supported by the system. Data flow models may be used to show the processes and the flow of information from one process to another. Behavioral models. Behavioral models are used to describe the overall behavior of the system. Two types of behavioral models are: number 1, data processing models that show how data is processed and it moves through the system. And number 2, state machine models that show the system's response to events. These models show different perspectives, so both of them are required to describe the system's behavior. State machine model. These models the behavior of the system in response to external and internal events. They show the system's responses to stimuli, so are often used for modeling real-time systems. State machine models show system states as nodes and events as arcs between these nodes. When an event occurs, the system moves from one state to another. State cards are an integral part of the UML and are used to represent state machine models. State transition diagram. The state transition diagram, also called the state diagram or state chart diagram, shows the life history for objects of a given class, the events that cause a transition from one state to another for those objects, and the action of the object that results from a state change. They are created for classes whose objects exhibit significant dynamic behavior. Initial and final states. The initial or start state is the default starting place for a state machine. The optional final state indicates the completion of the state machine's execution. Example: state transition for an order. Here is an example: state transition for an order. The diagram indicates the various states of an order. Beginning at the start state, we show an action triggering an initial transition into the checking state. This transition is labeled get first item. Note: usually event triggers are not permitted with the start state. The syntax for the transition labels has 3 or 4 parts, all of which are optional. Event arguments, guard condition. In this case, we only have the action get first item. Once we perform the action, Once we perform that action, we enter the checking state. The checking state has an activity associated with it, indicated by the label with the syntax do activity. In this case, the activity is called check item. Here's another example problem: cancel the order. Want to be able to cancel an order at any time. Solutions: transition from every state to state cancelled. Transition to cancel. Superstate or substate. Payment authorization. Data processing models. Data flow diagrams may be used to model the system's data processing. These show the processing steps as data flows through a system. DFDs are an intrinsic part of many analysis methods, simple and intuitive notation that customers can understand. Show end-to-end processing of data. Data flow diagram. DFDs models the system from a functional perspective, tracking and documenting how the data associated with the process is helpful to develop an overall understanding of the system. Data flow diagrams may also be used in showing the data exchange between a system and other system in its environment. The flow model. Every computer-based system is an information transform. Flow handling notation. External entity, a producer or consumer of data. Examples: a person, a device, a sensor. Another example: computer based systems. Data must always originate somewhere and must always be sent to something. Process. A data transformer changes input to output. Examples: compute texts, determine area, format report, display graph. Data must always be processed in some way to achieve system function. Data flow. Data flows through a system beginning as input and be transformed into output. Data stores. Data is often stored for later use. Data flow diagramming guidelines. All icons must be labeled with meaningful names. The DFD involves through a number of levels of detail. Always begin with a context level diagram, also called level 0. Always show external entities at level 0. Always label data flow arrows. Level 0 DFD example. The data flow hierarchy. Level 0 DFD or context diagram. This highest level DFD represents the system as a whole. Level 1 DFD. This is the level 2 DFD. Quiz software example. Level 0. Level 1 quiz software. Student admission example level 0. In this case, external entity student, process student administration process application, and data flows application form, confirmation or rejection letter. Level 1 data flow diagram. Semantic data models used to describe the logical structure of data processed by the system. An entity relation attribute models sets out the entities in the system, the relationships between these entities and the entity attributes. Widely used in database design, can readily be implemented using relational databases. No specific notation provided in the UML, but objects and associations can be used. Data modeling concepts. Data modeling concepts include attributes. Data attributes define properties of a data object. Relationships. Data objects connect to one another in different ways. Relationships. Cardinality. We must understand the number of occurrences an object has related to another object. Cardinality is the specification of the number of occurrences of one object that can be related to the number of occurrences of another object. 1. Relationship. 1 relationship. One object can relate to only another object. 1 n relationship. One object can relate to many objects. Mn relationship. A number of occurrences of an object can relate to many objects. ERD notation. One common form, another common form. Building an ERD. Level 1 model all data objects, entities, and their connections to one another. Level 2 model all entities and relationships. Level 3 model all entities, relationships, and the attributes that provide further depth. The ERD an example. Data dictionaries. Data dictionaries are lists of all of the names used in the system models. Descriptions of the entities, relationships, and attributes are also included. Advantages: support name management and avoid duplication, store of organizational knowledge, linking analysis, design, and implementation. Many case workbenches support data dictionaries. Data dictionary entries. Okay, friends, this is it for now. Thank you for watching this lecture, and please also share what you have learned from today's lecture in the comment box. Allah Hafiz.